Hi everyone, welcome to your first lesson on nuclear chemistry. As you can probably imagine, in our unit on nuclear chemistry, we're going to be talking a whole lot about the nucleus. So as a way to start off our unit, I think it's important for you to understand how scientists came up with the idea of a nucleus. Because, 150 years ago, no one knew what a nucleus was. That wasn't what we thought atoms looked like. So the goal for today's video lecture is to learn how a scientist named Ernest Rutherford discovered the nucleus. So 150 years ago, the scientists' understanding of the atom was very different from ours today. You guys have learned about the atom. You know that an atom is made up of protons, neutrons, and electrons, and that there's a nucleus on the inside and that electrons are on the outside. But that was not what people thought in the past, even only 150 years ago. 150 years ago, people thought the atom was just a solid sphere. So it was a solid circle with nothing smaller inside. So, this big green dot is what people, well, it wasn't necessarily green or this big, but people thought the atom was just a solid sphere. But then in the year 1897, along came a scientist named J.J. Thomson. J.J. Thomson is a very famous chemist. And he's famous because he was the first scientist to realize that there's something out there smaller than the atom. So again, previous to J.J. Thomson, everyone thought the atom was just a tiny, tiny little solid sphere. But J.J. Thomson discovered electrons. Now we know that electrons are inside the atom, so they have to be smaller. And that's what J.J. Thomson realized, was that inside of an atom are these tiny, 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 tiny little particles that have a negative charge called electrons. And so J.J. Thomson came up with a whole new model of the atom, which we now call the chocolate chip cookie model, which is a very strange name for a scientific model, but it's because we use a chocolate chip cookie to describe what the atom looked like. So a chocolate chip cookie has this sort of general dough and then these tiny little pieces of solid chocolate. Now, J.J. Thomson's atom had a similar sort of idea that he thought the atom was sort of this positive dough, or this positive, it's almost like a positive cloud with these tiny little electrons inside. So this positive circle represents the cookie dough, and these negative, tiny little negative charges, the electrons, which J.J. Thomson discovered, represent the chocolate chip cookie, the chocolate chips in the chocolate chip cookie. So the chocolate chip cookie is really just a metaphor for J.J. Thomson's model of the atom. So for a good 12 years, everyone was on board with J.J. Thomson's model of the atom, until the year 1909, when a new and very, very important scientist named Ernest Rutherford came along and did an experiment that would prove J.J. Thomson's model wrong. Now, Ernest Rutherford was actually a student of J.J. Thomson, and they got along fine. He didn't have anything against J.J. Thomson, but he did an experiment that was very famous called the gold foil experiment. And we're going to look at that right now. So here is a diagram of J.J. Thomson's gold foil experiment. Over here, you have what he's calling the alpha particle emitter. It's essentially, it's different, but you can sort of think of it like a laser. It's going to shoot out these beams of energy. And in that energy are these tiny little particles called alpha particles. So he's going to shoot this beam of alpha particles at a piece of gold foil. So a very, very, very thin layer of pure gold atoms. And then wrapped around that gold foil, he's got this screen, and that screen is called the detecting screen because it can detect alpha particles. So what J.J. Thomson is going to see is what happens to the alpha particles. Do they go straight through the foil? Do they bounce off? What happens? That's what he's going to look at. So first, like any good scientist, we need to make a hypothesis. So if it's 1909 and we're Ernest Rutherford and we believe in J.J. Thomson's model of the atom, we should predict that the alpha particles are going to go straight through. And that's what you see in this model right here at the bottom. So in this model, we've got J.J. Thomson's atom. The sort of pink beige background is the positive dough, and the blue dots are the negative electrons, or the chocolate chips. But there's nothing super dense or super hard or super big inside the atom. So the hypothesis is that the alpha particles will just go straight through. Right? So if J.J. Thomson's model of the atom is correct, the alpha particles should just go straight through the middle. Now, what makes this experiment so famous and sort of so important for Ernest Rutherford is that that's not what ended up happening. This is what ended up actually happening. So again, here's the beam of alpha particles. It leaves the little gun, it hits the foil, and a bunch of different things happen. Some of the alpha particles bounce back. Some of the alpha particles go straight through. And some just sort of bend. And we call that deflecting. Deflecting just means they got sort of bent in a different direction. So obviously, Ernest Rutherford is really surprised by this and really excited because he's clearly just discovered something really big. But the question is what? So he has to think, what could make this happen? If the chocolate chip cookie model is right, then the alpha beams would have gone straight through. So what happened? Rutherford decides that there must be something that they had missed in the atom. And he decides that somewhere in the atom has to be this really, really, really tiny, super dense, hard, heavy center. And that for these green rays, the ones that got bounced back, the reason they got bounced back is because they hit that center. And that's how Rutherford comes up with the idea of the nucleus. So you can see on this diagram down below Rutherford's new model of the atom, which is going to sort of replace J.J. Thomson. So we've got this cloud of electrons. That's the larger circle. And inside that cloud of electrons, we have the nucleus, which is this really, really, really dense, hard center. And so these rays that I highlighted in green up top that got bounced back, those correspond to this ray right here. And that the reason they bounced back was because they hit the nucleus, this really super dense, hard center. And these blue rays that just passed right through, no problem, and came out the other side of the gold foil are the rays that did something like this. So that the cloud of electrons doesn't do anything. The alpha particles can go right through the cloud of electrons, but it can't go through the nucleus. And then the purple rays are the ones that got close to the nucleus and then bent out of the way. So I like this diagram right here because it's got a nice comparison of the two models. So first we have J.J. Thomson's model, in which the alpha particles go right through. And the reason that they go right through is that there's nothing that gets in their way, right? This sort of positive dough and the chocolate chips, the alpha particles can go through them. They're not that hard. However, here's Rutherford's model. And in Rutherford's model, some alpha particles go through. The ones that go right through are the ones that are traveling through the cloud of electrons. But what's important, what's really different about Rutherford's model is that some alpha particles bounce back. And the suspicion, which it turns out is correct, is that they bounce back because they hit the nucleus. Now, this is just a quick little slide to give you a sense of just how tiny the nucleus really is. If an atom were to take up the size of a baseball field, so atoms are tiny, but if we pretend for a minute that the atom is as big as a baseball field, the nucleus would only be the size of a pea. So imagine a tiny little pea sitting on the pitcher's mound. That's the relative size of the nucleus to the whole atom. But the pea would be 1,000 times heavier. So the nucleus really is tiny, but it's extremely dense. So to wrap up for today, let's revisit our goal. The goal had been to learn how Ernest Rutherford discovered the nucleus. So you should be able to understand at least a little bit about how Ernest Rutherford used the gold foil experiment to show that the chocolate chip cookie model couldn't work, and how instead he came up with a new model of the atom where in the middle there's this tiny, hard, dense little